All right, so welcome back to the channel. Okay, today we have another question on the board. We have that 8 raised to the power minus t is equal to 9 plus t, and we're asked to find the value of t. We're going to use the Lambert W function to try to find the value of t. Let's solve this question together. All right, so we're going to start by dividing through by 8 raised to the power minus t. So we have just 1 on the left-hand side. Let's lay down the formula. The Lambert W function is a raised to the power ea equals a. This is what we're trying to achieve. So we'll rewrite our equation, and it becomes 8 raised to the power minus t divided by 8 raised to the power minus t equals 9 plus t divided by 8 raised to the power minus t. We cancel this out. On the left-hand side becomes 1 equals 9 plus t. And we can rewrite 8 raised to the power minus t. If we take it to the top, becomes 8 raised to the power t. Now, we have in the parentheses just t, and then in the power just t. And now, but we have 9 attached to the t in the base. So let's do the same for the power. Let's get 9 to the power. And to do that, we need to multiply the left-hand side and the right-hand side by 8 raised to the power 9. So now let's do that. 8 raised to the power 9 times 1 equals 9 plus t. 8 raised to the power t, 8 raised to the power 9. And we know that a raised to the power m times a raised to the power n is equal to a raised to the power m plus n. We can add the powers up. So let's do the same thing. Let's add the powers. Since we have the same base of 8, we can add the powers of t and 9. So this becomes 9 plus t, 8 raised to the power 9 plus t. Okay, so we're getting somewhere. We have that e raised to the power ln of x is equal to x. So if our x is, for instance, in this question, our x is 8, therefore it becomes e raised to the power ln of 8 is 8. That's what it means. So we're going to replace this 8 with e raised to the power ln of 8. So we're doing that because the Lambert W function requires that. We have the a here, we have the a at the power, there's an e. We need to introduce the e somehow. And this is how we introduce the e, by using the formula e raised to the power ln of x equals x. Now, so we have 8 raised to the power 9 is equal to 9 plus t, e raised to the power the ln of 8 raised to the power 9 plus t. Or 9 can come down here and becomes 8 raised to the power 9, 9 plus t, e raised to the power 9 plus t, ln of 8. Now we've introduced ln 8 again. So what do? We multiply both sides, left hand side and the right hand side, by ln of 8, so that we have that ln 8 at the base. That way, the base and the power have look the same, they look similar, and then we can apply the Lambert W function because we have an e there now. Okay, so multiply both sides by ln of 8, 8 raised to the power 9 equals 9 plus t, ln of 8, e raised to the power 9 plus t, ln of 8. This looks the same. 9 plus t, ln of 8 at the base and at the power. So we can now apply the Lambert W function on both sides. Okay, so we have W ln of 8 raised to power 9 equals, this becomes 9 plus t ln of 8. Right. So now let's rewrite the left-hand side, because that's our next task. The next task is to rewrite the left-hand side to look to fit into the Lambert W function. So we have ln of 8. Let's rewrite 8 raised to power 9 in such a way that it fits into the function. And when you add or subtract, whatever you do, we still get 8 raised to power 9. So let's rewrite 8 raised to power 9, and it becomes 8 raised to power 1 times 8 raised to power 8. Same base, we add the powers. 1 plus 8 is 9. So it becomes 8 raised to power 9. So that is sorted. Now let's rewrite it to fit into the formula. 8 raised to power 1 goes behind the ln of 8, okay? And multiplied by 8 raised to power 8. 9 plus t ln of 8. Now let's introduce our e raised to power ln of x formula for 8 raised to power 8. So it becomes 8 ln 8 e raised to the power ln of 8 raised to power 8. This 8 goes there. Let's write out the right-hand side. And this becomes w 8 ln 8 e raised to the power 8 ln of 8. 9 plus t ln of 8. So now we see that the base and the power on the left-hand side are both the same. So applying the Lambert W function, we have on the left-hand side 8 ln 8 equals 9 plus t ln of 8. Now we have ln 8 on both sides. They can easily cancel out. And what we have left is 8 equals 9 plus t. So therefore, our t is equal to 8 minus 9, because this 9 moves over from the right-hand side to the left-hand side to become minus 9. So our t is equal to minus 1. Now let's go ahead and verify, just to make sure that our answer is correct. So our equation is what? 8 raised to the power minus t, 9 plus t. So we have 8 raised to the power minus t equals 9 plus t. And we said our t is equal to minus 1. That was the answer that we got. So let's plug in minus 1 into everywhere we find t and find out if the left-hand side will be equal to the right-hand side. So we have 8 raised to the power minus 1 equals 9 plus minus 1. Minus times minus will give us plus. So this becomes 8 raised to the power 1. 9 plus minus will give us minus 1. So 8 is equal to 8. Therefore, the left-hand side is equal to the right-hand side. So therefore, the answer to this question, t equals minus 1, is correct. So if you've learned something new today, make sure that you like this video. If you like what I'm doing, subscribe. Make sure that you share this video so somebody else can learn something new as well. I'll see you on the next one. Bye-bye.